If you're a science enthusiast, you've probably spent countless hours pondering the mysteries of the universe. One of the most captivating questions that has intrigued both scientists and dreamers alike is the concept of time travel. Imagine being able to journey through time, witnessing historical events firsthand, or even peeking into the future to see what lies ahead. The idea is as thrilling as it is perplexing. Then, you need to hear this. Time travel isn't just a figment of our imagination or a plot device for science fiction movies. It's a topic that has been seriously considered by some of the greatest minds in science. But what does science actually say about the possibility of time travel? Is it something we can achieve, or is it destined to remain a tantalizing dream? Is time travel really possible? This question has been the subject of countless debates, scientific papers, and even philosophical discussions. To understand the potential for time travel, we need to delve into the very fabric of our universe and the laws that govern it. Time travel might sound like science fiction, and indeed it has been a popular theme in books, movies, and TV shows for decades. From H.G. Wells' The Time Machine to the Back to the Future series, the idea of moving through time has captured our collective imagination. But beyond the realm of fiction, there is some fascinating science that suggests time travel could be more than just a fantasy. But there's some fascinating science behind it. The concept of time travel is deeply rooted in the theories of physics, particularly those related to the nature of time and space. To explore this further, we need to look at the groundbreaking work of one of the most brilliant scientists in history. Thanks to Einstein's theory of relativity, we have a framework that allows us to understand how time can be manipulated. Einstein's theories revolutionized our understanding of time and space, showing that they are not absolute but relative and interconnected. This means that time can be stretched, compressed, and even looped in ways that defy our everyday experiences. We know time isn't the same for everyone. According to Einstein, time is relative and can vary depending on factors such as speed and gravity. This phenomenon is known as time dilation, and it has been confirmed through various experiments and observations. Time can actually slow down or speed up depending on how fast you're moving. This effect becomes more pronounced as you approach the speed of light. For instance, astronauts traveling at high velocities in space experience time more slowly compared to people on Earth. This is not just a theoretical concept, it has practical implications for space travel and our understanding of the universe. Depending on how fast you're moving, the faster you travel, the more time slows down for you relative to someone who is stationary. This has been demonstrated with precise atomic clocks placed on high-speed jets and satellites, which show slight but measurable differences in time compared to clocks on the ground, or how strong gravity is where you are. Gravity also plays a crucial role in the flow of time. The stronger the gravitational field, the slower time passes. This effect, known as gravitational time dilation, has been observed near massive objects like planets and stars. Imagine this. If you traveled close to the speed of light, you would experience time much differently than someone on Earth. This is not just a hypothetical scenario, it's a prediction based on the well-established principles of relativity. Time would pass slower for you. This means that if you embarked on a journey through space at near light speeds, you could return to Earth to find that many more years have passed here than you experienced during your voyage, compared to someone standing still. This phenomenon has profound implications for our understanding of time and our place in the universe. It suggests that time is not a fixed, unchanging entity but a dynamic and flexible dimension that can be influenced by our actions and environment. For astronauts on a super-fast spaceship, the experience of time would be drastically different from that of people on Earth. This is not just a theoretical concept but a real consideration for future space missions and the potential for interstellar travel. A few years in space could mean that decades have passed on Earth. This idea, often referred to as the twin paradox, illustrates the dramatic effects of time dilation. If one twin were to travel through space at high speeds while the other remained on Earth, the traveling twin would age more slowly and return to find their sibling much older. Decades have passed on Earth. This concept challenges our conventional understanding of time and raises intriguing possibilities for the future of space exploration and human longevity. This means astronauts would age slower than us. The implications of this are profound, not just for space travel but for our understanding of aging and the nature of time itself. And it gets even wilder near black holes. These cosmic giants have such intense gravitational fields that they can warp time to an extreme degree. Gravitational time dilation near these cosmic giants means time is so warped it almost stands still. If you were to venture close to a black hole, you would experience time much more slowly than someone far away from it. Means time is so warped it almost stands still. This extreme time dilation could theoretically allow for travel into the future, as time for the traveler would pass much more slowly than for those left behind. Theoretically, this could let us travel to the future. By taking advantage of the effects of time dilation, we could potentially leap forward in time, experiencing years or even centuries in a matter of moments. But what about shortcuts through space and time? Enter wormholes. These hypothetical structures could provide a direct route between distant points in space-time, bypassing the need for conventional travel. These theoretical portals could connect distant points in space-time, allowing for instantaneous travel across vast distances. The concept of wormholes is rooted in the equations of general relativity, which suggests that such shortcuts could exist under certain conditions, letting you travel between them instantly. This idea has been a staple of science fiction, but it also has a basis in real scientific theories. If wormholes do exist, they could revolutionize our understanding of space and time. But we've never found one, and the existence of wormholes remains purely theoretical. Despite extensive searches and studies, we have yet to find any concrete evidence of these elusive structures. And even if we did, we're not sure they'd be stable enough to use. Theoretical models suggest that wormholes, if they exist, could be highly unstable and prone to collapse, making them impractical for travel. Now, time travel to the past could create some problems, serious problems that challenge our understanding of causality and the nature of reality. Like the infamous grandfather paradox. This paradox illustrates the potential contradictions and logical issues that arise when considering time travel to the past. If you went back and stopped your grandfather from meeting your grandmother, you might never be born. This creates a paradox. If you were never born, how could you have traveled back in time to prevent their meeting in the first place? You might never be born. This paradox highlights the complex and often contradictory nature of time travel to the past, raising questions about the very nature of cause and effect. So, is time travel possible? The answer is not straightforward. While the theories of relativity provide a framework for understanding how time can be manipulated, the practical challenges and paradoxes associated with time travel remain significant obstacles. Right now, it remains theoretical, and would require technology far beyond what we have today. The energy and resources needed to achieve time travel, if it is even possible, are currently beyond our reach, and would require technology far beyond what we have today. But who knows, the future is full of possibilities, and our understanding of the universe is constantly evolving. Maybe one day we'll figure it out. The pursuit of knowledge and the quest to understand the mysteries of time and space continue to drive scientific discovery and innovation. What would you do if time travel were possible? The possibilities are endless, and the idea of exploring different eras and witnessing historical events firsthand is incredibly exciting. Let me know in the comments. Share your thoughts and ideas about time travel, and let's continue this fascinating conversation about one of the most intriguing concepts in science and fiction.